Hello everybody, this is Aaron from Sibling Rivalry, and today I'm going to be doing a tutorial. It's going to be part one of a multi-part video series. I'm not sure how many parts it'll be, but I'm going to do a quick tutorial on how to create your own 3D printed keyboard case using a few easy to use online tools. And if you can see my screen here, which ideally you should be able to see, you'll see that I've got a keyboard page here. This page called Keyboard Layout Editor, Plate and Case Builder by SwillKB, and I've got Tinkercad open. So, this is going to be like a multi-part sort of quick rundown, and let's get started. And cue the intro.
A machine that can make copies of almost anything.
Welcome back from the intro. So, the keyboard that we're going to be designing is actually based on a pre-existing circuit board. And that circuit board is the 9. It's a 9-key macro pad from 40% Club. You can see the URL up here. We'll also have that link down below. And yeah, essentially it's just a 9-key keyboard or keypad. Typically it comes in 3 parts. It would come with a bottom plate, a top plate for the switches, and the circuit board itself. The circuit board here has some advantages. It's designed to work flipped in either direction, so it doesn't really matter which way you put up on the top, it'll work either way. And it also works with all the different variants of Pro Micro Arduino clone controllers, so that's handy. And the firmware exists on a few other sites. Like, everything's kind of already set up for this keyboard, so it's a great starting point if you're not sure what you're doing with mechanical keyboards. So yeah, let's get into this. So I've already downloaded the all the files from here, and we'll go over that in a future video a little more in depth. So what I'm going to start doing is I'm going to go to the keyboard layout editor, and if we look back here, we see it's 9 keys, so it's a 3x3 grid. So what we're going to do here is we're going to set this to a blank layout just up at the top in the preset, and we're going to add 3 keys. Now once we have the 3 keys selected, we can just do Control C and then Control V, and you can use your direction pad on your keyboard to move these around, and they'll move by quarter increments. So, and that's the standard sort of increment, so to speak, for most mechanical keyboards. Is everything's a quarter or variant of a quarter, or like a multiple of 0.25, so to speak. So now that we have this laid out here, there's the 9 buttons. I almost said 6 buttons, 9 buttons. We don't really need to do too much here in that regard. There's a few things we can do with this in the future that I will show you guys, but for our purposes right now, for 3D printing the case, all we need to do is go to this raw data tab, and we just copy the text, I guess, I would call it, or the code that is here, and just do Control C, copy it, and we'll just leave this open just in case we need to go back to it. And now we're on builder.swillkb.com. This is the plate and case builder. So this is a wonderful site from Swill, who's a member of the keyboard community. And what this site does is it takes the layouts from this keyboard layout editor and it generates a CAD file. So that is a DXF or an SVG. Both are vector files. If you're familiar with what that sort of thing is, a vector essentially is just lines. It's not particularly... I won't get too into that. It would get complicated. So we're just going to paste everything in here, just Control V. And we are using Excuse me. Standard MX switches, which are the ones you see here. So you just click that. You can leave everything pretty much as its default until we get to case type. Now at case type, we are going to want to click sandwich case, and we want to toggle this switch for the USB cutout. So the USB cutout is essentially going to be a hole through one of the layers of the sandwich case. So the way the sandwich case works, it's essentially stacked layers of laser cut or machined material that build up a three-dimensional case, similar to 3D printing. And you're going to see how that relates to 3D printing in a second. So for now, I'm going to increase the cutout width. By default, it's 10 millimeters. I'm going to increase it to 15, just because from my past experience with this site, for most USB connectors, 10 isn't quite enough. That's a centimeter. And yeah, a centimeter can be, depending on the plug, could be a little too narrow. So it's better to have a bit of wiggle room than not. So now we're going to go here, and you can see I've got some autofill stuff from using this in the past. But if you don't have that, you can just type in the numbers. So the mount holes, we're going to have 4 holes. That's going to be 1 for each corner. Diameter, we want to go with 3 or whatever size screw you're using. So 3 is for an M3 or a 3 millimeter screw. If you're using a metric screw, you would come up with or if you're using an imperial screw, I should say, you would want to use like a conversion and figure out how many millimeters or approximately that is. You can always go a little undersized, and that's fine. You just drill out the holes manually afterwards. Now, for this part, for the edge width, this is the width of material in which to place the holes. So this gets a little tricky because it's not the same as edge padding. Edge padding is essentially the barrier from the outer wall, like the outer line, to the inner line. So if you're doing like a internal layer, you would essentially just have a perimeter around a void, so to speak. And you'll see what I mean in a second. So for this, I'm going to go with 6, and I'm going to set these to 5, and this is kind of I'm just playing with this at this point. I'm also putting a radius on here. Oops, I've got an alarm going off. I'll have to check that in a second. So I'm going to go with a 6 millimeter radius, which should nicely complement the 3 millimeter holes and everything else. So I'm going to leave the rest of these alone. Let's see if we can draw the CAD. So, yep, you see you have to change edge width. Yeesh, I can't speak today. Edge width, or padding values. So, and it gives a nice description there. I need to reduce this. So I'm going to go with 2.5. And let's see if we can draw this CAD. No. Okay, edge width measure must be greater than the hole diameter in order for holes to have material around them. So let's go with 4 and see what that gives us. And it just generates the CAD here. Everything's done on a server. So yeah, this isn't going to work. We want these holes to be further in, but you can kind of see what I was talking about the different layers here. So let's go back here, and the great thing is we just keep going back and forth. As long as this plate layout is retained in there, you should be good. So I am going to go with, let's see what I've used before. I have used 6, 9. Let's see. Draw my CAD. Oh, yeah, it needs to be greater than the edge width. Okay, so let's set this to 10. I usually do 5, so I'm not sure what the problem is here. And this should give us something like what we're looking for. Ideally. This might just take a little bit of trial and error. Oh, yeah, that looks exactly like what I want. So yeah, that actually should be perfect. Yeah, I might move that in a little bit more, those circles. So let's do 10 and see if that works. It doesn't do anything weird. Because I'd like these to be evenly spaced in there, which it looks like they are now, or as close as possible without messing up other things. So that should be good. And what we're going to do is we're going to click this, but you're going to want to open this in a new tab. So you can right click, open a new tab. This is going to save as an SVG. So let's save as, and we're going to save this. I'm going to create a new folder here just to be on the safe side. Keep 9. You know what? We'll just call it the 9 plates. And we're going to go in here and save this as switch plate. Just because the auto-generated title is kind of a little hard to follow. It's a lot of just characters. It's a string of random characters, or maybe it's hexadecimal or something like that. I don't know. Doesn't really matter. And we're going to do this again. And this is the... Oh, let me just go back here and check. Oh, did I made a boo-boo. Let's check and make sure. Oh, yep, I just deleted everything I did. Well, this is fun. Always open in a new tab, kids. Okay. Sandwich. Edge padding. What is going on here? Oh, it's doing that. Okay, so it retained the information, it just didn't retain the plate layout. So that's fine, thankfully. So it'll generate the same thing that we saw before. Just gonna scratch my leg. Alright, so open a new tab. I'm just using the middle click on my mouse. If you're not aware of that, you can just middle click with a mouse to open in a new tab. That works on Windows, and it should work on Mac computers as well if you have a Mac mouse that has a scroll wheel or a middle button. And this is what I was trying to do. So this is called open layer, that's called close layer, that's called top layer and bottom layer. So save as, open layer. We'll close that. Save as, closed layer. And closed layer and top layer are going to look pretty much identical. Actually, I think they are literally identical, which is fine. We'll save it as a separate thing because it'll make our lives a little easier. Top layer, and then bottom layer. Okay, so now that we have that generated and all those SVG files saved, which you want to do this as an SVG, if you're using other software or CNC, you might want to use DXF or EPS, but for what we're doing, SVG works great. So I've got a new project open in Tinkercad. So what I'm going to do here is call this 9... let's call this the 9 bottom. We're going to do the bottom and the top as two separate parts. You could do them on the same work area if you'd like, but I like keeping them separate so that it's easier to separate them in the future if you need to. So we're going to import an SVG. So that is going to, we're going to go into 9 plates, and I said we're doing the bottom, right? Okay, so what better to start with the bottom than bottom layer? And you want to keep scale to 100, and yep, just click import. It'll import it here, and it should automatically extrude your SVG into a three-dimensional file. So what I like to do, which you can make these as thick as you want, but what I like to do is have them be 3 millimeters thick for each part. And that works great for me. And then what I'm going to do is just keep importing the different layers. I might actually skip the closed layer and just have an open layer take its amount. So let's import this. So that is now on top and through. I am going to scoot it so it's just on top, and we're going to merge these in a second. If you're not familiar with Tinkercad, we might do a video on that in the coming weeks. I've tried doing a video on it before and there were some weird computer issues, but it should work perfectly fine now. So yeah, we're going to set this to 6 millimeters because it's the equivalent to 2 layers, and depending on how your experience goes with this, you might want to increase it or decrease it. It's really based entirely on your preference. I think actually I'm going to increase it by another amount. I'm just going to go up by an interval of 3 and get it up to 9. I could have probably left it at 10 and it would have been fine. I want that extra little bit of thickness in there. And the great thing about doing it this way with 3D printing is if you're not exactly sure how thick it needs to be, you can adjust and you won't have any real problems with that. So yeah, you can always kind of just adjust, like reprint, and it won't take a whole bunch of material. So yeah. Okay, now I am going to merge this. I'm going to go pink and brown, and we're going to go up here and merge objects, or group objects, I believe is what they call it now. So we have now made the bottom case for our keyboard. So what we can do now is export this as an STL. Lots of sounds today. Alright, so I'm going to go back to the main Tinkercad dashboard, and we're going to start a new project, and it's going to use the top layers. We're going to do a similar thing. So click Create New Design, and we're going to go call this 9 top, click Import, choose a file, we're going to do switch plate, import, and it's probably going to do the same thing. It's going to import as a default of 10. This is something you definitely want to keep around 3 millimeters thick. Ideally, you would want to make it a little bit less than 3 millimeters, or you can modify it a little bit to kind of have the switches clip in. It isn't too important that the switches clip in because they're going to be held in place primarily by the circuit board in conjunction with this, but it's always good to kind of keep things as they are. So let's choose a file. We're going to import the top layer. And in this case, we can actually leave it intersecting with that. And let's see, let's set this to, yeah, let's just set it to 9. It'll be a little thick, but it'll be like a high profile case for the keyboard. And that should kind of cover up switches if you're one of those people who doesn't want to see the switches on their keyboard too much. You can always remove this top layer if you want to just have the switch plate. I know some people like just having the switch plate showing, so we're going to go and do the same thing we did with the last one and merge these together, or group them I should say. And what you can actually do here, if you want to, you can take a little box, and we're actually going to shrink this down quite a bit. If you're finding that the switches aren't sticking well enough for you, you can shrink this box down to, I believe it's about 3 millimeters or so. Don't quote me on it. Yeah, we'll do. Yeah, let's shrink this down quite a bit. And Tinkercad is freezing up on me. A web-based program, freezing. Lovely. Okay, so we're actually going to make this 5 wide, and that should be more than enough. Yeah, you know what? We're just going to do it this way. 5 millimeters. There we go. And I know that the switches are around 19 across, so what I'm going to do is actually just set this to 20. And what we're going to do is take, oh, that's not what I wanted. I wanted to move this, not stretch it. So we're going to shrink this down quite a bit. Actually, 20 is probably overkill, looking at it now. And we are going to go about half the height of this. It's small enough that overhangs shouldn't be a real problem. But you can go like this, and we're going to shrink that down just a little bit so it isn't too big. I think that is more than enough. Yeah, you know what, 1 millimeter in on each side should be enough. So let's see this side. Is this? Ooh. Okay, now we're going to group this with that. And what this is doing, it's creating a little cavity here that the clips on the switches themselves can stick to. So that, oops, sorry, just moving everything here. That will allow the switches to stay stuck in there. So, yeah, you don't need that per se. I'm actually not going to include it in mine. I'm just going to export this as an STL, and what you can now do, you can open up your slicer. I'm using Prusa Slicer. I'll do a video on this for you guys in the coming weeks. And with Prusa Slicer, you just go here, and you can see 9 top and 9 bottom. Let's open up the top. And there you go. You've got your STL that you can 3D print, and that will allow you to make this case rather than having to get it laser cut. So that's pretty awesome in my books. Now what I'm going to do, I realize I missed this, I've actually ordered some threaded inserts, some heat set threaded inserts from Amazon, and I'm going to use those on the bottom plate here. And that will allow me to thread in. You can actually thread into these with the screws themselves, the holes will most likely be a little undersized compared to the 3mm of the screw. And from there, you could just screw it straight in. But if you want a sturdier connection, you want to increase these holes right there to have enough space to do the heat set inserts, which I'll show you in a future video of this series, how to do the heat set inserts. But what we're actually going to do, rather than go back and forth, so to speak, and modify this pre-existing one, I am going to create a new project. And we're going to create a bottom plate specifically for heat set inserts. So we're going to do 9 bottom heat set. And what we're going to do is go back to our plate builder, and we are going to increase the size of these holes. So the inserts that I've bought, and this will vary depending on which inserts you buy if you decide to use the inserts, mine are, the outer diameter of the insert is 4.2mm, and you actually want to make this a little undersized. So I'm going to do 4.1. And let's draw a CAD. Let's see if that worked. Now we're not going to have to re-download all the files here. We're actually just going to need to download the bottom file, like the bottom plate, and the bottom, like, not the bottom, but the open layer. So I'm going to open that up in a new tab, and you know what, for the bottom layer, I'm actually going to do something, again, a little different. Why do all the work yourself when you can get software to do it for you? So I'm going to take out the holes. And that will give us a bottom that's completely flat and doesn't have any insert holes. So, also if you wanted to just use super glue, you could just do it this way. You just glue all the plates together, but screws are usually a preferred option because then you can disassemble and modify if need be. So, I'm going to download the bottom here. So, let's save this as, let's call it the open heat set layer. Open layer heat set. .svg, and there we go. It is saved. And save as, bottom layer heat set. Alright, so we're going to import those files. Bottom layer heat set, import. And we're going to change that to 3mm. If you wanted to add like little inset spots for the feet, like if you're going to add little rubber bump-ons for feet, you could do little insets for that, and I might show that in a future video, but for right now, I'm just doing a 3mm flat base. What I might do is put some grip tape or some neoprene on the bottom. And there we go. Choose file, open layer heat set. Okay. Now this, if memory serves, is at 10. So yeah. For this one, just to account for the heat set inserts, I'm going to give it that extra millimeter. What you want to do with a lot of heat set inserts is give it a little bit extra depth for it to go in, because it's going to push the plastic as it goes in and kind of build up a little wall. So you want to give it a little bit extra space, and that extra millimeter isn't going to hurt us. I might actually end up changing the other one to being 10 millimeters plus the 3, so 13 millimeters total in height, because it really doesn't hurt. So, oh, cancel. I wasn't trying to import, I was trying to join. Oh, geez. You can tell I'm tired. Okay, so that is done as well. So, let's export that. And that should be perfect. And the lights are turning off, which tells me that it is pretty much time for this video to end. And I'm just going to go open up Prusa Slicer, show you guys this file in there, prove that I'm not crazy, I guess. I don't know. I am crazy, it feels like. But, yeah. There we go, 9 bottom heat set. And there we are. And we'll go over the 3D printing of this in a future video, and I'll talk about all the different things you can do to kind of make these as durable as they need to be, different infills, and it'll actually be a bit of a tutorial on Prusa Slicer, which I'm finding is so much better than Cura, for the Kingroon at least. Well, it's better than the default Cura that came with the Kingroon by a long shot. And yeah. Well, I'll show you that in the next video. So if you enjoyed this, please give us a thumbs up. We really appreciate that. It helps a lot. If you like this content and you're not subscribed, please subscribe. We're going to have more of it in the future. And if you are subscribed, please don't forget to ring that bell so you get notified whenever we upload new videos. We're doing regular content on Mondays, bonus content on Thursdays. And yeah, thanks again for watching. I hope you have a great day, and bye for now.